So students, today we will discuss one of the most important topic in mathematics, set theory. Set theory. You might have heard about union, intersection, Venn diagram. These are very important and common words. And you might have often come across these words during your class 8, 9, 10th standard, like A union B, A intersection B, these kind of diagrams. This is A, this is B, this is U. So today I will discuss this set theory right from the very beginning point. Okay. I'm not going to define you what is set. I know everybody knows what is set. Set means like kind of objects keeping together, like an array or separated by comma. Those kind of things I'm not going to discuss. What I'm going to discuss is like what is the, let me write down the things I'm going to discuss. Important things to discuss. First, meaning of universal set. This is important, very meaningful thing. Second, meaning of union of two sets, or I will stretch it up to three sets, or union of three sets. Meaning of intersection of two sets or three sets. And the most important one, the fourth one, different kind of languages. Rather, you can say mathematical languages used for A union B, comma A intersection B, or A union B union C, or A intersection B union A intersection C union B intersection C. These kind of things. I mean, how to pronounce these things while solving a question or while reading a question, how to relate the actual wording of the question with A union B, A intersection B, or A union B union C. Like, if I can give you an example, suppose I write number of elements in number of elements in at least one of A and B. So this language is also related to set theory, these kind of things, union, intersection, and we need to correlate it with these kind of symbols, union, intersection, while solving a question. So this is very important to understand the language described in a question and to correlate it with the mathematical language. So number of elements in at least one of A and B. What is the meaning of this with respect to union or intersection? How to relate it with sets? So these kind of things, like one more statement, let me write. number of elements in at least two of A, B, and C. This is another language which can be, or you can say, which must be correlated to set theory. So you might get surprised with these kind of languages, but this is the truth that we need to understand. We need to correlate these languages with sets. So let me start with the first one, meaning of universal set. The first one, what is the meaning of universal set? Meaning of universal set. Say A and B are two sets in a discussion. Say A represent number of students in a classroom speaking English, and B represent number of students in a classroom speaking French. Can you justify me like number of students who speaks English and number of students who speaks French? If I combine both of them, then I will get the total number of students in that classroom. Can you justify like A plus B is number of students in A and number of students in B? A plus B is equal to total number of students in the classroom? No. So if I make the biggest set, the largest possible set in the discussion related to the discussion, then that set is universal set. Like this classroom is universe for this discussion. So this is universal set. Universal set. This classroom. Universal set is this classroom. And maybe another circle C, D, E, maybe somebody speaks Spanish, somebody speaks some another language, and those A, B, C, D circles all will come under this classroom, this universal set. So universal set is the biggest set in the discussion, and all discussions related to that particular situation comes under that universal set. So as for number of students concerned, so the total number of students representing that classroom is this universal set. Now, what about this A and B? A means students speaking English. What does the set B means? Students speaking French, right? Okay. Now quickly come to the point. What is the meaning of A union B? Now this is the universal set. You suppose the classroom, and I'm making two circles, one A and one B. This is students speaking English. This is for a student speaking French. And this is common to both students speaking both English and French. Now you must concentrate on the phenomena, like use of particular word is very important in these kind of situations. You cannot mismatch the words. Like if you say number of students speaking English is represented by set A, then it doesn't mean they speak only English. This is true, they speak English, but this is not true that they speak only English. In same way, if you say set B represents number of students speaking French, it doesn't mean set B represents students speaking only French. They speak French, but they will speak only French. This is not true. So this is justified. This red stripes portion, this is justified. This is students speaking both English and French. This may occur that we can have some students who speak both English and French. Now, what is the meaning of A union B? What is the meaning of A union B, or an A union B rather? This is number of elements belonging to either in A or in B or in both. This is one of the language. Mind the language. Number of elements belonging to either in A or in B or in both. Now, either in A means this is pure A. Pure A means only this portion, this dotted portion. Let me show you black dots. This dotted portion is pure A. This is pure A. No involvement of intersection part, common part. And suppose put red dots. These red dots is pure B. No involvement of intersection part. And this intersection part is both pure A and pure B. So this is pure B and this is both. So N A union B means all these portions once. Pure A once, pure B once, and both part once. This is once, this is once, and both part also once. Once. Only once. If you go by area, then once area of pure A, once this area of both, once this area of pure B. Area doesn't mean the geometrical area, it means the number of elements situated in that area. Pure A, number of elements situated in that area A and B, number of elements situated in that area pure B. Now there is another another language for A union B. This point I was talking about the different languages. The fourth point, different kind of languages used. So intersection and union part is simple, but language to correlate it is, a bit different. So number of elements belonging to either in A or in B or in both is any union B. The other language is for same any union B means number of elements belonging to at least one of A and B. Now what does it mean? At least one of A and B means either in A or in B or in both, because at least one means it can go up to both. So this is having the same meaning either in pure A or in pure B or in both. Let me write it. Means either in pure A or in pure B or in both. Now we can derive a formula from this Venn diagram. This diagram is called Venn diagram. Okay. The square diagram containing two circles is called Venn diagram. Two circles, three circles, whatever the situation demands. Now, What is the formula for NA union B? This is now simple. Pure A, number of elements belonging to pure A. This intersection part means A and B both, number of elements belonging to both. This is in fact both means both at the same time means A intersection B. So this intersection means both. Intersection means both at the same time. Both at the same time. So NA union B will be equal to NA plus NB minus NA intersection B. Why this minus? This minus is very meaningful because this Na is not pure A. Na is not pure A. Na includes an A intersection B. Na includes an A intersection B. So we need to remove it once because NB will also include an A intersection B. NB is also not pure A. Pure B, sorry. Also not pure B. It also includes an A intersection B. You can easily see in the picture like the set A contains this intersection part. Again, set B also contains this intersection part. So if you write NA union B is equal to NA plus NB, you will be in big trouble because NA and NB both will contain intersection part and you will add intersection part twice. But what we need these three diagrams only once. So we need to subtract this once because NA intersection B is counted twice, once in A and once in B. And we want all the diagrams only once. So this is the correct formula and this is the wrong formula. And what is the mathematical meaning of NA union B? Elements belonging either to A or to B or to both, which can be pronounced like number of elements belonging to at least one of A and B. So whenever you get the word at least one of A and B, you should understand it is A union B, number of elements in A union B. And whenever you get the word both at the same time, A and B, then it is A intersection B. So I hope you understand this NA union B thing. And if you understand this NA union B thing, then in my next lecture, I will explain you what is NA union B union C. Suppose there are three circles. So I explain what is the meaning of NA union B union C in my next lecture. Let me write the formula first and then I will derive it. You can also try to derive this because once you understand NA union B, then you can also understand NA union B union C. So this will become this minus B intersection C minus C intersection A plus NA intersection B intersection C. So you try proving this formula NA union B union C. The meaning of this is what? Number of elements in at least one of A, B, and C. Number of elements belonging to at least one of A, B, and C. Now, what does it mean? Elements can belong to pure A or pure B or pure C or pure A intersection B or pure B intersection C or pure A intersection C or pure A intersection B intersection C, but only once. Once in all the structures. Like this part once, only once, this part only once, this part only once. Now intersection part only once, this part, this part, this part, and this part only once. All the parts only once. So this will be the formula. So you keep trying this, and I hope if you understand NA union B, then you can also understand NA union B union C. Thank you.